coins that use the same algorithms. That one's working, but things have not been that great in mining. The second coin we were talking about didn't pan out so well for us. Some changes in that algorithm. So we're focused now on a second generation chip, which is much more advanced, much more flexible. Rather than being a dedicated crypto miner, it's actually a CPU-based architecture, many CPUs in an array with acceleration hardware for a few mining algorithms. And of course, we're also seeing, sorry, is that working better? Okay. We're also seeing other applications for that architecture, such as AI, of course, everyone's working on now. A few other things in scientific computing. Most of the applications you see today for graphics cards, we think we can do it a bit better cost to performance than those guys. Based on our latest figures, mining revenue from the first production lot of this chip would be around $3 million per year. Of course, that's subject to change. It won't be up and running for nearly a year yet. We do think the other applications could be potentially an order of magnitude greater than that. We're still fleshing out that model. And we're looking for about $4 to $8 million for this round, just the Series B. That's mostly for costs of putting the second chip into production, mask sets, and so on. Most of you know how mining works. The work miners do secures the blockchain against changes to past transactions. Whoever wanted to change it would have to repeat all that work, and we get rewarded with newly created currency. Most of you also know how it goes from CPUs to GPUs to ASICs. In our case, we're somewhere between an ASIC and a more flexible GPU-like architecture. Total market for the currencies we're going after is around $1 billion per year of total global mining revenue. The currencies we're going after are many of the major ones except Bitcoin. Bitcoin mining is another $5 billion or so. We're not targeting that yet because it really does require a totally specialized chip. The company started in 2017. We had an FPGA design for FPGAs are flexible off-the-shelf chips that can do many of the things an ASIC can, but not as well, or not as cost effectively. We raised a $300K seed investment to put that into a ASIC form. There's some straightforward pathways for that. Pretty quickly after that, we realized there was capital available from the same group to go directly to a much more sophisticated ASIC. We raised a $5 million Series A in 2018. Pre-money for that was 7.5 M. This round we're going for 4 to 8. More details on how we'll use that later. Mostly need that to tape out the chip to production, which we're targeting March or April of next year for. Quick overview on our Gen 1 chip. I'll actually have one of these just show you in a minute. It works as expected, which is a bit of an accomplishment. The rest of the system was more challenging. Cooling power has been a big struggle for most companies to enter this space. Delayed us, but we've worked that all out. One of the major currencies we were targeting, which many of you will guess, switched algorithms specifically to defeat ASICs, and we had thought we could adapt to that with a change order, and we could not, or at least not very easily. Hence, we're now focused on a completely programmable architecture. And we do have these chips online producing revenue. Not a fantastic amount, but at least a demonstration of their potential. This is the board we built. I can show you one of these in person in a minute. The large array of parts is our design, and power supply on the left, and the logic that controls them all on the right. Gen 2 is a completely different architecture. We're starting with a completely programmable RISC CPU. It's an open source instruction set, which is widely supported by compilers and so on, so this can compile and implement just about any algorithm or other function. We have a pretty clever high-performance interconnect fabric, which ties over 1,000 of these cores together so that they can work in parallel, much like a GPU, but also with a higher degree of independence in each core than a GPU. And we're adding a few more features to support other applications, floating point arithmetic, a few other gadgets, which we'll get into. Major currencies, Zcash, Ethereum, Litecoin, probably no surprises there. One or two other major ones. And being a completely flexible architecture, we can target any new currency that comes along, any new algorithm that there are no competing ASICs for, and potentially do very well in those. This is a comparison chart. I'm moving fairly fast here because we're limited on time. Major advantages. We think we're the only current company focused on a completely programmable architecture. There have been a few people who have talked about it in the past, but no one has actually implemented it successfully as far as we're aware. Of course, there are a number of other companies doing crypto mining ASICs, a lot of you know. Most of them are focused on Bitcoin, a few others on altcoins and so on. We do have, as I mentioned, we have dedicated logic for a few of these algorithms that are highly competitive, like script. There would be no way to do that on a truly general purpose processor, so we add logic for those features. And by supporting many algorithms, we remove a lot of the risk that would be attached to designing a chip for any one particular currency. A little on IP. We hold it all as trade secrets now. We are looking at some patent opportunities. Mostly interested in patenting things that apply to more general applications, since the crypto market is dominated by Asia, and also many companies, including us, don't sell their chips to the public. So there's no real way to prove infringement. There's no way to, hopefully no way to actually copy a design, reverse engineering. And we have some interesting gadgets around encrypting our software. Since it's largely a crypto processor, we can hold a lot of the application information confidential. We can control it through licensing and so on, even after we release these chips to the public. Other applications, kind of interesting area. Right now there's 101 companies creating AI processors, including a lot of the big guys, Google, NVIDIA, Amazon, and so on. We think we can do that at least as well as they do, and we think we have some advantages in that they are completely specialized on AI, and there's dedicated pipelines through their chip, which limit their flexibility. We, having a completely programmable core and a completely programmable or real-time routable bus interconnect between those cores gives us increased flexibility for AI apps and also other things. Another major area we're interested in is finite element analysis, FFT, biological modeling, a number of scientific applications that involve processing large matrices, and people have been using GPUs for these for years. The big limitation of a GPU is moving data between cores. We need more than one core to process the same section, or rather, we need the same section of matrix to be processed by many cores. It becomes a major bottleneck. You have to share that data across all of them, and the only way they really share is by writing out to a slow external memory. So that's one area where we think we can have a significant advantage. Commercializing this is something we're just starting to explore. We already plan to build significant sized data centers for our own mining, and so a natural model would be AWS style, renting these resources out for other people's computing applications. And of course, our data centers are a bit lower cost than Amazon, since we don't need 5 nines availability. Performance, roughly equivalent to recent NVIDIA Tesla GPU, the same kind that Amazon sells. That's not really difficult. We just put the same number of multipliers on it. Also similar to some of the AI-specific chips that have been announced. The data on those isn't very clear because most of them aren't available for sale. Adding these capabilities doesn't cost us much, since we already have most of the hardware for crypto. That's why we're entertaining the idea. It's a lot easier to dual purpose these things without adding cost to the chip. Economics, Tesla T4 runs for 50 cents an hour on AWS. AWS total earnings are around $2 billion per quarter. Of course, we'd only hope to capture a small amount of that. And our cost is quite a lot lower than the Tesla retails for. We have a lot smaller chip, a lot less overhead for all the legacy things that an NVIDIA GPU has to support. And we don't know their margin exactly. We do suspect their yields are quite low on those large chips. They have to make quite a few wafers to get one good chip, hence driving the cost way up. Ours is smaller, doesn't need to be as big, and so yield on a die per wafer basis is much better. Some revenue projections by coin here. These, of course, will change a lot in the coming year. In short, that on a few of the more profitable algorithms, the chips pay for themselves on about a 1 month time frame. On the less profitable coins, you're looking at many months. That's how things tend to go these days. The market's mining revenue worldwide has been fairly weak lately, and for those highly competitive coins, we're only a little bit better than the other guys. This is our projection for earnings growth, going to around 10 million a quarter, based mainly on those higher margin currencies. The lower margin currencies are actually much deeper markets, but they take a lot larger scale to exploit. In those cases, we'll be building these in large volumes and selling them to others. Planning to have that model online around 2021, just because of the challenges in marketing a consumer product, regulatory, and so on. I have a little bit here on the supporting systems we've built. This is a power supply front end we've developed in-house. Takes a 40 volt 3-phase input compared to most server supplies, which only take 240 single phase, so quite a lot more cost effective. That is prototyped and basically working. This is an immersion cooling system we've been designing, oil bath based. A number of miners are using these types of things. We've also experimented with a phase change system, which works very well, but it has some reliability issues that a lot of people have run afoul of. We think we've solved most of those, but it's on hold until we have a little more bandwidth to prove it out. A little bit on scaling here. We've scouted around. We found some locations. We have some shareholders out in Washington where the power is cheap, including some contractors, people who can get us a data center set up pretty quickly. We've explored moving some of the less power-intensive stuff to Puerto Rico for the tax advantage. That's, of course, a bit complex logistically, but an option on the table. This is going into some of the business models we are planning to implement in the future. We, of course, can mine for ourselves, but that becomes a threat to the network. If we encroach on 50% of the total capacity, we could threaten security. So eventually we have to share with others. We probably implement contract mining first. That's Genesis, for example. We can sell these to others. That's more complex due to regulatory and reliability concerns. We'll get to that in 2021, we think. And of course, we can host the miners we sell, much like Bitmain and others do. Going into some more detail on these models here, but I think most of you probably know how they work. We're short on time. Team, it's myself, founder. We have a VP engineering we're trying to recruit who has experience with another startup in this field, also in Austin. 2 contractors we've been working with, both likely going full-time in the near future. One focused on the power and infrastructure, and one focused on helping out with the chip design and verification. 2 major advisors. One is our lead investor, very well-traveled and experienced international businessman. A few of you might know him. And another CEO that I worked with previously in the solar industry and also has experience in a few semiconductor startups. We also have a CFO we're courting at the moment. Partners, we're manufacturing with TSMC. Many of you know them. They're the largest merchant foundry in the world at the moment. Global Unichip is a branch of them that assists with back-end physical design, also a very large company that we've worked with in the past. We get into schedule here. These are details, but in short, we'd be trying to get these chips released to manufacturing in April. We got them back in July, have them online by September of next year. Budget is about $6 million to tape out a leading node ASIC. That's why we're here. We have a few million in the bank from our Series A, but we would like to raise at least another $4 million to finance this. And there are a few extra features which we have to license from others, and those can add up to 2 or 3 million. So we're looking for 4 to 8. If we get to the higher end of that range, we will have some very interesting capabilities regarding multi-chip networks, external memories, things like that. We have some more financial details here. We're almost out of time, so we'll skip over these for now. Gen 3, we have a few ideas to work on in the future. There will, of course, be a die shrink of this chip eventually, assuming it's successful, to a more advanced node like 7 nanometer. We have some architectural ideas, mostly things we're trying to rush into this design, but if there's no time for that, we'll push them to Gen 3. We have some more FPGA-like architecture that we have been experimenting with, but there's overhead associated with that. We're still trying to optimize it. And the instruction set we've chosen is still developing. It's a large open source project itself, so we'll be supporting new features for that, and of course, any new mining algorithms that come along. And if this is successful, of course, we can branch into Bitcoin. We have some good ideas about how to build a great Bitcoin chip, but the market for that is very competitive right now. You would need at least 20 or 30 million to break into it. So we're putting that off for a later date. That's it for this. Welcome any questions and comments.
It may have been on one of the slides, there's a lot of them, but I was, what percentage of the revenue from the production of the chips comes from mining versus selling the chip eventually?
The revenue on this slide was almost entirely from mining internally. Going forward, the last quarter on there, I believe, was Q4 of 21. And going forward from that, we have to focus more on selling them. For applications like Litecoin and Ethereum, we don't really want to have gigawatts worth of these things in our own garage. So that'll be more of a large-scale production and sales model.
Yeah. How much of the optimizations in, I'm trying to figure out how to ask this question. They're like going from code, like going from like an algorithm, right? Like a math algorithm down to like actual chip, like electricity moving through a chip. There's obviously a lot of improvement that you can make like in hardware, and then there's a lot of software, of course, and like strategy that kind of take advantage of the chip design. Is it a fair question to ask, like, what kinds of optimizations have you made, or what kind of advancements have you made on the actual software side, or like, how much room do you see for improvement on that?
On the software side, our starting material is the C code from the various currency projects that we're trying to mine. Usually there's a poorly optimized version of that that's easy to understand, and then the mining software writers do extremely optimized versions for specific architectures like x86 or GPU. Those implementations aren't useful to us because we have a completely new architecture, so we write our own software that's targeted to it. And in the cases where we have hardware acceleration, that software is very simple. It just invokes the hardware accelerator over and over. Hardware acceleration is a more manual process. There actually is an automatic route to do it, but the results are poor. So we handwrite RTL code, which is basically a text schematic of a logic circuit that performs these functions. And we do pretty well on the first try, and then we analyze power consumption, analyze timing, speed, clock rates, and the tools show us where we need to work on it from there.
So like in the Gen 1 chips, so like since they went into production, you've been iterating on the RTL code. How much improvement have you seen on those as you've gotten better at that?
For the narrow functions we did on Gen 1, what we released for Gen 1 was fairly optimal to start with. We've made some small improvements, but
thanks for getting up there and presenting. Appreciate it. One maybe constructive criticism is that it's a little bit hard to read all like the words. So unless this is targeted at like a very specific technical audience that just wants that might be a good like read ahead or something, and then just focus the slides on like some big ideas.
Visual.
Yeah, but I mean, I'm sure there's a ton of really pertinent specific things, but someone that has never seen this before is kind of flat.
right. Yeah, I know it's an eye chart. We'll try to clean it up a bit. Thank you.
Yeah, so just to summarize here, what you guys have made is basically started with an FPGA, right? And then what you're advertising essentially is a reprogrammable ASIC, right?
It's a CPU array, which is programmable in the same way that any CPU is.
Right. So over the last 5 years, dealing with multiple mining algorithms with Digibyte, right? Because we have 5, we just launched like Ludocrypt, which is an algo that reprograms itself every 10 days, just for the exact reason so specific ASICs can't be made for it, right? And so what I'm trying to discern here is, for instance, for those that may not be familiar with mining, if you buy a SHA-256 ASIC, the only thing you're ever going to be able to do with it is mine SHA-256.
Exactly. We can compile the source code from GitHub for any algorithm and run it.
Okay, so that's cool. So the hardware, I guess, from the investment standpoint, is super good because it's not like you're just stuck with one particular mining algo.
Exactly.
Yeah, okay, yeah, that's perfect. I was just trying to clarify that.
That'd be cool if you put that up front then.
Yeah, that's what I'm saying. It's just like right
Yeah.
after. Because like, that's the big setup.
I think we had it on slide 1, but I'll make sure. Thanks.
Yeah.
Yeah, completely programmable architectures, that's what he meant by that,
Right.
right?
Right, 'cause, yeah, most of like the Bitmain ASICs, like once they're obsolete, like yeah, there's a couple other algos and coins you can mine, but for all intents and purposes, you spent $20,000 on something that effectively is a doorstop. So
Yeah.
Exactly. I've done that.
you can reprogram and repurpose towards another mining algo and another crypto. That's cool.
Yep. Thanks.
How important is a super fast backend, the network connectivity, the data center, the bare metal that's there? We're building data center networks. We're also building networks now inside buildings for MEC, multi-access edge compute. And there's just a lot of excess capacity that's not used because businesses use it for 8 to 5 typically. Now you got all this excess stuff that's going to be hitting the market. Is that important to this or not so much?
It matters, but it's not critical. Roughly, if you have a block period that's 15 seconds to 600 seconds, you can take your latency times some small number, and that's the percentage. Divide that by the total block period, and that's the percentage you're going to lose due to latency, roughly. So if you get it under 100 milliseconds, you're talking about 1% maybe.
What about compute?
Compute capacity?
Computing all of this stuff. You get it from AWS or somewhere else. Is that cheap? You don't have to worry about it. You can do it in 4 data centers on the edge.
Our computation we would do in our own data center. Okay.
No, I don't have a question.
I saw on there was it says liquid cooling, right? Is that going to be something that is sold to the public in that model, or is it something that only is put into certain data centers?
If we start selling to individuals, then we'd most likely implement air cooling as well.
Less efficient.
It's it's more expensive and less efficient, and so we can do it with the package we have now, but it's not ideal for a large-scale operation.
Gotcha. I just want to follow up on that. So your chips, are they all going to be in the data center, or are your chips going to be distributed in multi-data centers or multi-places?
Initially, when we get the first slot back, it'll be one data center. We'll eventually likely have a few of our own, and by 2021 or so, we'll be selling these to other people who put them all over the world. All right. No other questions? Thank you all very much.
Good job raising. You did great. And still have a couple million in your bank account. Well done.
Thanks. And if any of you would like to get in touch with me, my email's right there. I'm unfortunately out of cards, but you can talk to me today or drop me an email. Thanks a lot. Got our show and tell right here.
Oh, nice.
Yeah,
Well, we
lots of
need a
closer
picture.
look.
Matt, will you take a picture?
Yeah, whatever.
Now shake it off and throw me some Bitcoin. Here you go. There you go.
Does that work?
Oh, yeah. Wait, let's take. Oh, whatever. Did you buy?
Maybe some Dogecoin.
Well, thank you for coming, everybody. It's such a pleasure to see all of you. I really appreciate that you made your time and came to enjoy our company. And I'm looking forward to seeing you on December 2nd. Remember, it will be a Christmas party, and I will probably dress up as something from, winter holidays, because it will be December and we officially can't do that. So, and I welcome all of you do the same. Thank you very much.